Welcome guys, today we are going to discuss the third chapter of chemistry of NCERT 12th class, which is chemical kinetics. So first of all, what is chemical kinetics? So it is the branch of chemistry in which we deals about the study of rate of reactions and its affecting factors. Let's say a simple reaction in which a reactant converts into product, and here the which reactant convert into product, the reagent is used to convert reactant into product. So this is a simple reaction. So this may be proceed in the form of velocity in three types. Let's say first is fast velocity reactions, second is moderate velocity reaction, and third is slow velocity reaction. So what are fast velocity reactions? These are the reactions which take just seconds to be complete. These take just seconds to be complete, and all the ionic reactions are fast velocity reactions. Let's say an example of ionic reaction HNO3 plus KOH. This is the example of fast velocity reaction, and it is an ionic reaction. So the ions will break in H plus and NO3 minus, K plus and OH minus. So these ions will be break like this. So the further the reaction will move in the forward direction like that. K NO3 plus H2O. So this is the fast velocity reactions, and this type of reaction take just seconds to be complete. What is moderate velocity reaction? These are the reactions which take 5 to 10 minutes to be complete. Let's say simple example I2 plus H2. When it's react, it take 5 to 10 minutes. So it's the example of moderate velocity reaction. What is slow velocity reactions? These reactions take months and years to convert reactant into product. In the basic life, we can see the corrosion of iron. Corrosion of iron is the example of slow velocity reaction. So on the basis of velocity, the reactions can be divided into three types: fast, moderate and velocity. Let's move toward the next topic of this chapter, which is rate of reaction. So what is the meaning of rate of reaction? Rate of reaction, and it is represented by VR. It can be represented by any term symbol VR, CR. In the different book, different symbols are given. So let's say it is represented by VR, rate of reaction. So what is the definition of rate of reaction? It is defined as the change in concentration of reactant and product per unit time is known as rate of reaction. Let's say it will be represented by, it is defined as change in concentration of reactant and product per unit time is called rate of reaction. Let's say simple reaction, reactant converts into product. So let's say its concentration was C1. After few time, its concentration changed to C2. At time it's T1, and at time T2 it's changed to C2. So at the initial condition, product was 0. After some time, the product can become a value of, let's say, A. So after a time, this reactant converts completely into product. So this is the rate of reaction. Let's say basic example how the reactant convert into product. Let's say there is reactant which convert into product. First reactant is 100% at t is equals to 0 second, and the reactant is not formed, so it will be 0. After few time, the reactant at some second, at half second, let's say take at half second 50%. So half amount of reactant, it will be 50:50. Half amount of reactant is converted into product. And the reaction is completed when 100%, the complete reactant is converted into product. So you will see that the reactant will be 0 and product will be 100. So you will see that reactant convert into product is concentration of reactant. Let's see a graph about it. It is concentration and it is time. Let's say it is time. So we will see how the concentration of reactant decreases. Concentration of reactant decreases with increase in the time, and the concentration of product increases with increase in time. So it is the concentration of product which increases and is the concentration of reactant. It's the basic intro how the reactant and product convert into each other. So let's move towards rate of reaction again. So what will be the formula for rate of reaction? It will be change in concentration del C upon del T. So now we can write it as change in concentration C2 minus C1 upon T2 minus T1. Here C1 is initial concentration. It is initial concentration and C2 is final concentration. And here similarly T1 is initial time and T2 is final time. So this will be formula for rate of reaction. So you will see that rate of reaction is always positive. This term is always positive. But rate change in concentration may be positive or negative. Rate of reaction is always positive, but change in concentration may be positive or negative. You can write as a star point. Rate of reaction is always positive, but change in concentration may be positive or negative. How this is positive or negative? Let me explain in the forward way. See, rate of formation, reactant convert into product. So there is the rate of formation. There is the rate of formation of product P. So it will be represented by del P upon del T. And there is this product is being formed in the reaction and reactant is going this deformation. So if we write the deformation, rate of deformation of reactant, it will be represented by del R upon del T with the negative sign, because reactant is converting into product with time. So reactant concentration will be decreased. So negative sign will be always put when we will write rate of deformation for reactant, and if we will write for the rate of formation for product, then there will come positive sign. So for you can learn that rate of formation positive sign will come, and for rate of deformation negative sign will always occur. So this is all about rate of reaction. So what is the unit of rate of reaction? So see, let's derive from this formula. So this formula is change in concentration upon del T. So concentration unit for rate of reaction. Unit of rate of reaction. So concentration upon time, it is written, concentration can be written upon mole, upon liter, and time can be written as second. So unit of rate of reaction will be mole, liter inverse, second inverse. This is the unit for the rate of reaction VR. This liter will go downward in the denominator, so it will become inverse, and second will become inverse. So this is the unit of rate of reaction. So now discuss the next topic. What is rate constant? What is rate constant? And it is represented by K. Rate constant is represented by K. So what is rate constant? Represented by K. In this we will see that A and B both are converted into product, let's say. So from deriving the formula for rate constant, so by using law of mass action, we will write this term in the form of rate constant. So VR is directly proportional to the concentration of A and B. So by the definition of rate constant, rate of reaction is always directly proportional to concentration of A and B. If this proportionality sign is removed, the rate constant K will become here and the concentration of A and B will return here. Let's say A and B concentration is taken to be 1. Now the rate of reaction is equals to K. So by this theorem, we can derive that rate of reaction is equals to rate constant. Rate of reaction is equals to rate constant always when the concentration of A and B is unity. So what are the factors which affect the rate constant? So first, factors affect the rate constant. So this is case represented as rate constant. So first factor is nature of reactant. Nature of reactant. A and B. A and B is the reactant. So its nature also depend upon the rate constant. Second is temperature. And third one is catalyst. What is the meaning of catalyst? So catalyst is that which does not participate in reaction, but it increase or decrease the reactivity of the reaction. So it never participate in the reaction, but it increase or decrease the reactivity of the reaction. So these are the three factors which affect the rate constant. Let me explain you again about the rate constant. A and B is converted into product according to law of mass action. According to law of mass action, rate of reaction is directly proportional to concentration of A and B. Now the concentration proportionality is removed, so the rate constant K will come, and let the concentration of A and B will unity. So rate of reaction is equal to rate constant. From this derivation we have derived this equation. So now let's move toward the next topic. Before moving the difference between rate constant and temperature, you should know the properties of log. A little properties are there, you have to know it in a well defined manner. Log properties. So first property is, if log m upon n is written, how will be it will be written in the form of log m minus log n will become. So if there is divide in the log m upon n, this will be replaced by the negative sign, and if it is in the multiply log m upon n, then it will be replaced by positive log m plus log n. These are two important terms. And third is, if log m power n, so this power will become in front, it will be become n log m. So it will be these are the three properties of log which we will be used in the further derivation to find the zero order, first order. So all these properties will be used. And fourth is log ln x. It can be written in the form of log is 2.303 log x. This is most important. We will use these terms in the several times. Log x can be written as 2.303 log x in the form of this. This will be used in the derivations. So now let's say, what is the value of log 1? So the value of log 1 will always be 0. Similarly, value of log 2, you should learn this value in a proper way. Log 2 value will be 0.3, log 3 value will be 0.4, log 4 value will be 0.6, log 5 value will be 0.69, log 6 value will be 0.7, log 7 value will be 0.7, log 8 value will be 0.9, and log 9 value will be 0.95. So these are the log values which you have to learn in a proper way. These will be used too much in the derivations. And if log 10 comes, then it will be 1. If log 100 comes, it will be 2. If log 1000 comes, it will be 3. So number of zeros, and that will be the value of log. You can also calculate, if you don't want to learn, you can also calculate. How you can calculate? See, log 10 value is 1. So what will be the value of log 100? By the help of this, we will calculate the value of log 100. So in this, log 100 can be written in the format log 10 into 10. It is 100. So now we will use this property. So if the log m and n are in the multiply, then it will be plus. So it will be by using the property of log 10 plus log 10. By using this property, this value will come off. Now what is the value of log 10? It will be 1. And what is the value of log 10? Again it will be 1. So answer will be 2. So log 100 value will be 2. So you can see that you can similarly calculate for log 1000. It will be 3. So these are the properties of log which are very important in the further derivations. So next move towards the next topic, which is difference relation between rate constant and temperature. So next topic is relation between rate constant and temperature. So we will see the difference between rate constant and temperature. So Arrhenius, this theory was given by Arrhenius. So according to this, when temperature is increased, rate constant which is represented by K, it also increases. When temperature increase, rate constant increase. But when the temperature is increased by 10 degrees Celsius, increased by 10 degrees Celsius, rate constant become double or even more than double. So when temperature increase, rate constant increase. But when the temperature is increased by 10 degrees Celsius, rate constant K, which will become double or even more than double. So for this, Arrhenius give a equation which is known as Arrhenius equation, which is K is equals to AE minus EA upon RT. So here K is rate constant, A is Arrhenius constant, and EA is activation energy. So R is gas constant, and you should learn this value of R. It is 8.314 joule mole Kelvin. So it is the value of R, and T is temperature. And the thing that the temperature should always be taken in the Kelvin. When we will solve the numericals problems, the temperature should always be in the Kelvin. If it is given in the Celsius, let's say it is given 20 degrees Celsius. So how we will convert 20 degrees Celsius into Kelvin? So simple, add 273 into this. So it will be 293 Kelvin. So if anything given into Celsius, we will add 273 and it will become into Kelvin. So this is important term, you can note it for the further derivations. So now these are the terms which have been used in this Arrhenius value equation. So now we will solve how this reaction by the taking log. So this is equation of Arrhenius, and we will solve it by taking ln both side. By taking ln both side. So what it will become? Ln x is equals to ln k is equals to ln a e की power minus ea upon rt. This term will be same, and we have taken ln both side. So now by using the property of log, so we will write this ln m into n. It can be written as ln m plus ln n. So now we will write this. This will become same, and this will become ln a. This is m and this is n by this formula. So we will put the values. So there will be, if these are in the multiply, plus sign will become. So it will become ln e minus ea upon rt. So now we will solve further. ln k, ln a. Now this, by using this property, ln m power n, so n will come forward, it will become n log l ln m. So we will use here this. So this term will become forward, so it will become minus, because minus e upon rt is in minus, minus e upon rt ln e, and value of ln e is 1. You should remember this, value of ln e is 1. Now solving further, it will become ln k is equals to ln a minus ea upon rt. So this is the first equation. So you can also draw the graphs of this equation. So let me tell you how to draw the graphs of this equation. So let's say this is the straight line equation, y is equals to mx plus c. So the graph for this will become, this is y axis, this is x axis, and this is intercept c, so it will become this. So this is the graph for this y is equals to mx plus c. It is first. For second straight line equation, y is equals to mx. So for this, what will be the graph? It will be slope. This will be go through origin. So this is y and this is x. Here the slope is m, and c intercept is this c intercept. Here the slope will be m, and there is no intercept c. Value of c in this will be 0. So now the third graph for this is, so now the third graph, let me draw here. Now the third graph for this, y is equals to minus mx plus c. So for this, here the slope is negative, so we will draw this similar graph but in the slope in the negative. So this will be this, like this. So intercept c will be this, and this is y axis, and this is x axis, and this is slope minus m. So these are the three important graphs which will come again and again used in this further derivation of zero order first order. So you can write it in a proper way. These are the three graphs of straight line, y is equals to mx c. This is slope, and c is the intercept. And this, and if there come y is equals to mx, this will be origin, go from the origin at point 0, straight line. And if the slope is negative, this line will be go downward and in this negative. So we will draw for this. So which will be, so which equation will be for this? So it is y is equals to, and what is the, and this is c, and 1 upon t is become mx. So 1 upon t is x, slope is e upon r, and c is ln a. So we will draw graph for this. So graph for, we will draw this graph for this. Similar graph, no change. See, y axis, at y axis it will become ln k, and at x axis it will become 1 upon t. And slope is negative, so it will become like this, and slope is e upon r. And what will be the value of intercept c? It will be become ln a. So this is straight line equation, y is equals to minus mx plus c. It is written in this format. So this is the graph for this, which is very important, which is asked in the mostly in the NEET examination and also JEE examination. So let's move forward. Now let's take rate constant k1 and k2 for equation first, and temperature T1 and T2. Both these values will be put in the equation first. So it will become ln k1 is equals to ln a minus ea upon r T1, because we have taken rate constant k1 and temperature T1. So this is equation second, and similarly we will put at k and t k2 and t2. So equation third will become as ln k2 is equals to ln a minus ea upon r T2. This will be equation third. So by equations third minus equation second, we will get the final result. So equation third, ln k2 minus ln k1, we will see, we will minus equations third by equation second. So we will get the final result. So it will become ln a, and this both ln a and ln a will be cut because this equation will be minus by this, and we will get final result as e upon r 1 upon t1 minus 1 upon t2. This we will get. So now using again the property of log, if log is in log, property of log, that ln m minus ln n, this is similar, so we can write is ln m divided by n. This term will be also come in this format. So what it will become, ln k2 upon k1, and this we will write further the same. So now what we can write ln in term of log. So we will write that ln can written in the term of log. ln is equals to 2.303 log. So we will, this is in term of log. So we will write same by using this property, 2.303 log k2 upon k1, and this term will be further used same, e upon r 1 upon t1 minus 1 upon t2. So this will be, this 2.30 will be go in denominator, so it will become log k2 upon k1 e upon r e 2.303 r 1 upon t1 minus 1 upon t2. So this will be the final result. So this will be the final result starting from this arrhenius equation, k is equals to ae minus e upon rt. By taking log ln both side, it will become ln k ln ae minus e upon rt, and by solving the property of, by taking the property of log, this term will become forward, this will become, and the value of ln e will be 1, and we will get the equation first. Now taking two different condition of rate constant k1 and t1 and k2 and t2, we will derive two different equation. So this is equation second and this equation third. By equation third minus equation 2, it will become ln k2 minus k1, and this term will become, and we will further solve this, final result will become. So it is very important result, you can mark as it star mark. So now we will discuss the next topic, which is temperature. What is temperature coefficient? What is temperature coefficient? Temperature coefficient, which is represented by mu, which is represented by mu. So it is the difference between two rate constant of two different temperature which have difference of 10 degrees Celsius. So I repeat definition again. It is the difference between two rate constant k1 and k2, let's say, of two different temperature t1 and t2, which have difference of 10 degrees Celsius. So this formula will be used. So this formula for this temperature coefficient will be Vf is equals to Vi V initial to k power T2 minus T1 upon 10. So this is the formula for deriving temperature coefficient. By putting the value of T2 and T1, we can get the final. This is rate of reaction at final, and this is rate of reaction at initial. So let's move at next topic, which is factors affecting rate of reaction. This is important for the board examination. Factors affecting rate of reaction. What are the factors which affect the rate of reaction? In the video, I have told that reactant convert into product, and which factors which will affect the rate of reaction. The first factor will be nature of reactant. The first factor will be nature of reactant. So in this nature of reactant, we will study physical and its physical property and its chemical property. In physical property, we will write rate reaction as physically gas, then liquid, and then solid. Why the rate of reaction will affect more for the gas? Because in the gas, all the particles of gas are at different and larger distance. Let's say it is a container, and in which there is gas molecules. So the gas molecules will be at larger distance from each other. And if it is in liquid, these molecules will be little close, but in solid it will be completely, all the molecules will be completely attached with each other. So this is physical properties for the rate of reaction. And if it is what, and if chemical properties we will study, then when the activation energy is decreases, then rate of reaction will be increases. So what is activation energy? We have derived it from the arrhenius equation, that K is equals to AE minus EA upon RT. So what is activation energy? EA. We have written activation energy as EA. So what is activation energy, which is represented by EA? So activation energy is that it is a minimum amount of energy for a reactant molecule to convert into product. When the reactant molecules is converted into product, that minimum energy which is required, to convert reactant into product, this is known as activation energy. So when this minimum energy is decreases, then rate of reaction increases. So this is the nature of reactant. Next it will affect, factor will be which affect the rate of reaction is concentration of reactant. So when the concentration is increased, rate of reaction will be also increased. Let's say example of it, A is converted into product B. If the concentration of A increases, then rate of reaction will be also increases for this reaction. So it also affect the concentration of the reactant. Third will be pressure. Pressure also affect the rate of reaction. When the pressure increases, rate of reaction also increases. This is simple. When the pressure increases, rate of reaction also increases. Fourth factor is catalyst. So first of all, what is catalyst? These this does not participate in reaction, but it changes speed or velocity. So there are two type of catalyst. One is positive catalyst and another is negative catalyst. Positive catalyst and another is negative catalyst. When positive catalyst is added in the reaction, then rate of reaction increases because there is decrease in the activation energy. And similarly, if negative catalyst is added, rate of reaction decreases because there is increase in the activation energy. So this is concept for the catalyst. When the positive catalyst add in the reaction, rate of reaction increases because it decreases the activation energy. And if negative catalyst is added in the reaction, it decreases the rate of reaction because it increases the activation energy. This is all about the catalyst. Fifth point is temperature. When the temperature is increased, then rate of reaction will be also increased. For every type of reaction, either it is exothermic or it is endothermic. So what is difference between exothermic and endothermic? If exo and if endo comes, if exo comes, then we can say that heat is released, and when endo come endothermic, then heat is absorbed. So for both these exothermic and endothermic reactions, when temperature increases, rate of reaction also increases. So these are the five factors which affect the rate of reaction. First is nature of reactant, second is concentration of reactant, third is pressure, fourth is catalyst, and fifth is temperature. So now let move toward the forward topic, which is theories of rate of reactions. What are theories? This is also important for the board perspective. Next is theories of rate of reaction. So in this we will study two theory. First is collision theory and second is ACT, which means active complex theory. So first let's start from the collision theory. This theory was given by Arrhenius. In this theory, reactant molecules convert into product by colliding with each other. In this theory, this reactant is converted into product. When the molecules of reactant collide with each other, then the formation of product is output of formation of product comes. So we can understand in the simple that the minimum amount of energy should be there for reactant molecules so that it convert into product, and this minimum amount of energy is known as collision frequency, and its value is very high, 10 to the power 25 to 10 to the power 20 10 to the power 28 second. It is known as collision frequency value. For collision theory, its value is very high. So in these two factors affect the collision theory. It is first is we require effective collision between the molecules collision, and second is minimum amount of energy for a reactant molecule to convert into product. So first is effective collision. So reactant molecules collide with each other and form product. Let's say it is a molecule A, and when it collide with molecule B by effective collision, it is a simple example. We will take complex example further. So this will become like this. It is proper and effective collision, and this reaction will be proceed further. Let's say if these A and B are in the opposite direction, one is horizontal and another is vertical. So there will be no reaction. So let's take a little different example for this. This was the basic example. This is carbon and its 4 valency is occupied by different atoms. This is bromine, which is a larger size atom. When OH, which is electrophile, when it attack on carbon, so due to this high size atom of bromine, this reaction will not proceed further. So it will be no reaction. And if this OH minus attack from the another side of this, if this will attack, no reaction will proceed. And if this attack from the different direction, this reaction will be proceed. Now OH will be attacked on carbon and bromine will be removed here. So this is nucleophilic reactions, and OH will become here simply. So now you have seen that this bromine is removed from here. This bromine is removed from here because this is effective collision. Reactant molecules is converted into product, and this is not effective collision, so this reaction will not be move further. And next is minimum amount of energy. Effective collision, and second is minimum amount of energy. So minimum amount of energy for a reactant molecule to convert into product is, reactant molecule must have minimum energy so that it should convert into product. So this is collision theory, and these are the two factors. You can write it also. Second theory is ACT, which is called active complex theory. So in this theory, when reactant is converted into product, an intermediate is formed, and this intermediate have more energy than the reactant and product molecules. Let's take an example. See that H bond is formed when it react with I2, an intermediate which is also called active complex will be formed. The bonds will be break partially. This is called activated complex. So now further this reaction is, this is also intermediate or activated complex. Intermediate also you can say that. and activated complex. So now this reaction will be further move and these bonds will be break and the formation of Hi plus Hi. So this intermediate have more energy than the reactant and product molecule. So this theory, SCT active complex theory only explains that reactant, this is reactant molecule, this is intermediate and this is product. So this reactant molecules have more energy than the reactant and product. This is explained by the active complex theory. So now move further for what is difference between order and molecularity. It can be separated. What is molecularity and what is order? First is what is molecularity. These are very simple topics. So molecularity is the number of reactant molecules which take part in the reaction is known as molecularity. Let's say this is a simple reaction XA plus YB and the product is formed. So number of reactant molecules, number of only see the reactant molecules, number of reactant molecules which take part in a simple reaction. So we will take stoichiometry of A and Y. So molecularity for this reaction is, for this reaction will become X plus Y. And now take the different example. Let's say when CO react with O2, so it will be become 2CO2. So now, so this reaction is now balanced. When CO2 react with O2, so molecularity for this is, molecularity for this is 2. We will see number of reactant cut 2. So the molecularity for this reaction is X plus Y. Now we will see further. Let's take a basic example. Simple I2 plus H2 plus 2Hi. For the molecularity for this is the number of reactant molecules which take part in the reaction. So number of molecules is just 1 and 1. So molecularity for this reaction is 2. And if this reaction is reversed, let's say this reaction is like this 2Hi plus I2 plus H2. So similarly molecularity will be again 2 because the number of molecules which take part in the reaction is again 2. So you can write molecularity as number of reactant molecules which take part in a simple reaction. Big example. CS3, COOH, COO, C2H5 plus H2 is added in this reaction. What is the molecularity for this reaction? And further this reaction will become like this CS3COOH plus C2H5OH. So molecularity is number of reactant molecules take part in the reaction. So molecularity will become 2. Number of reactant molecules, stoichiometry is 1 and 1. 2 molecules, so molecularity will be 2. Now, and the property of molecularity is that molecularity is calculated always theoretically, whereas order is calculated practically, and it never be zero, fraction or negative, whereas order can be zero, fraction or negative. Let's compare both. What is order? So it is order is sum of power raised to the concentration of reactant and product. Simply, let's take this same example that it is sum of power raised to the concentration of reactant in rate law equation. We will write in the rate law equation. Same example XA plus YB because we are comparing both molecularity and order. Let's say product is formed. So what is the order for this reaction? So it is the sum of, so order, definition of order is that it is the sum of power raised to the concentration of reactant and product. Only reactant. So it will be rate constant in the rate constant form. X will come here and B or Y will come. So we will add the concentration of product. We will add both and we will get order. So order for this reaction is X plus Y. So this is order for this reaction. So a simple reaction take sum of power raised to the concentration in rate law equation. This is rate law equation. We have derived it further, rate law equation. So it is order, and order is always calculated practically. Whereas it can be negative, whereas this cannot be, this is cannot be, and it can be zero fraction or negative, whereas it cannot be zero fraction or negative. So these are the major difference between molecularity and order. So next, let's start the next topic, study for the various order reaction. In this we will study zero order reaction, first order reaction, and nth order reaction. So next topic is study of various order reaction. Study of various order reaction. In this we will study first order, second order, nth order, and zero order. First we will study zero order reaction. What is zero order reaction? Zero order reaction. In this, reactant concentration does not depend upon the concentration of reactant. Let's say A is converted into product. So at time t is equals to 0, the concentration of A is, let's say, small a, it is represented, and the product is not formed, it is 0. After t second, it will become x time less and this product will be formed. X. Both these sums will become A. Let's see that x plus x, x minus A minus x, and when these both are added, the result will become A. So this in this, the rate of reaction, which is represented VR, does not depend upon the concentration of reactant. So concentration of reactant is this. So it does not depend. So the power will become 0, and any power, if any power is 0, it will become always 100. If 100 power is 0, it will become 1. Always come 1. If power is 0, always result will become 1. Anything power is 0. If 1000 power is 0, it will become 1. If 2 power 0, it will become 1. So always it will come 1. So this term will become 1, and this rate of reaction can be written as dx upon dt format, and k will come here. So now let's take dt, this left side, it will become del t. So now on integration this equation, this equation, del x upon k dt, integrate at x is equals to 0 to x is equals to x tak, and from t is equals to 0 to t second, it will become, on integration dx will become x, and it will become k t, and this is the, on further solving this, k is equals to x upon t. This is the formula for a rate constant of zero order reaction. So what will be the graph? It is the simple straight line equation of y is equals to mx. So this will be y, k is equals to xt. So this is y, and this x will be slope, and 1 upon t will be x. So the graph for this will be go from origin. So y-axis is x, y-axis value for y-axis will become k, and value of x is 1 upon t. So 1 upon t will become here, and slope will be x. This is slope. So in the format of y is equals to mx, this is y is equals to mx format, we can write this equation as like this. So this is graph. If k, this formula can be further derived as this. If k is written as this, at minus a naught upon t, this same formula can be written as like this. So the difference come is, a naught is initial concentration, t is final concentration. So this formula can be written like this also. So what is, now we will discuss half-life for zero order reaction. Half-life. What is half life? When half amount of reactant is converted into product, means 50% of reactant is converted into product. Let's say A is converting into product at T is equals to 0 second, it is 100%, and that product is not formed, and at half time half amount of reactant is converted into product, so it will become 50 and product will be also become 50. Now at T is equals to 100 time, reaction is completed 100%, so reactant will become 0 and product will become 100. So half life is represented by T half or T 50%. So by using this formula, we will get T 50%. This K will be go downward, 80 minus A naught upon K, and value of 80 is A, and value A by 2, and value of 80 is A, and value of A by 2, A naught is A by 2 and K. Now for further solving T 50%, it will become A upon 2K. So this is formula for T 50% for zero order reaction. This is formula for 50% for zero order reaction. Now we will discuss first order reaction. So no change in first order reaction. In this first order reaction, reactant concentration depend upon rate of reaction. In first order reaction, rate of reactant concentration depend. First order reaction. In first order reaction, reactant concentration depend upon the concentration of rate of reaction. So let's see an example. Simple. A is converting into product at time t is equals to 0. It is A and product is not formed, so it is 0. At t second, A become few lesser A minus x and product will form x. So now what will be further? So in the first order reaction, rate of reaction depend upon concentration of reactant. So it will be written VR is equals to K times of A minus x, and here power will become here 1. And in zero order reaction we have taken power 0, so it complete term become 1. So now rate of reaction can be written as dx upon dt K times A minus x. Now on solving this further reaction, it will become del x dx upon A minus x upon K dt. Now what we have to do, do integration of this term. On integration of this term from dx upon A minus x is equals to K dt. K is constant, so we will put out from the integration. So now we will integrate in this. So you should know that integration of 1 upon x is ln x, and if integration of 1 upon minus x, it is minus ln x. So we will use this property here. So this integration will become minus ln A minus x. This negative of x will come here, and here k t plus c constant will become. So at initial state, to find the value of constant at initial state, x was 0 and t was also 0. You can see that at this is initial state and this after final. So x is 0, you cannot see x, and t is 0. So we will put the value of this here ln A minus 0, and this whole term will be 0 is equals to c. So c value will become minus ln A. So now putting this value of c in equation first, we will get ln A minus x is equals to kt minus ln A. So now further solving, we will put this terms this side, we will get ln A minus x is equals to kt. Now we have to find the value of kt. So kt is equals to, it will become, t will be go downward, ln A minus x upon t. So if ln m minus ln n is written, we can write it in divide ln m upon n. So this term will be going divide ln a minus x, and t will be remain here. So we can write ln as ln can be written as 2.303 log. So we will replace this k is equals to 2.303 log a minus x upon t. So this is the formula for first order reaction. This is the formula for first order reaction. Now by the help of this formula we will calculate half life for first order reaction. So what is half life? Half life means half amount of reactant is converted into product by using this formula. K is equals to 2.303 log a minus x. So half time half amount of reactant is converted into product. So x value will be a by 2. So now putting the value of x in equation 2, a by 2, half life will be t half. This will be become t half. This will go this side, and k will become downward. 2.303 upon k log a minus x value will be a by 2. So it will become a by 2. Now on solving further, 3.303 k log a, and it will become a by 2, and this 2 will be go upward. 2.303 k log 2, and what is the value of log 2? Log 2 value will be 0.3. On putting the value of log 2, it will become t half is equals to 3.303 into 0.3 upon k. So by multiplying this 2.303 into 0.3, we will get direct result 0.693 upon k. This is the final result for calculating the t half for first order reaction. So these are the methods to calculate first order reactions, zero order, second order. So what is the nth order? Direct we can calculate by the, we will not learn this complete process. This is only for the board, and if you are preparing for the competition exam, you have to learn the nth order. We will help you to calculate first, second, third, whatever order it will be. So for nth order reaction, what will be the formula? So formula for with this is Kt is equals to 1 upon n minus 1 upon 1 upon 80 n minus 1 minus 1 upon a naught n minus 1. This is formula for the nth order reaction. N can be any term. Here n can be any term. 0, 2, 3, 4 except 1. We cannot calculate it for first order. It can be calculated for every. Let's say let calculate for second order reaction. What will be second order reaction? So we will put simple value of n is equals to 2 and put in this formula. So Kt is equals to value of put 2 here. It will be become 2 minus 1 upon 80, and here 2 minus 1 it will become 1 minus 1 upon n naught, again it will become 1. So for further solving, k is equals to 1 upon t 1 upon 80 minus 1 upon n naught. So it will be for second order reaction. Similarly, we can calculate it for third, fourth, fifth order reaction by using this formula. And the last topic is how to calculate unit for different order reaction. So the basic formula which will become for to calculate unit is concentration 1 minus n second inverse. Now we will calculate unit for zero order, first order, second order by using this formula. So put the value, calculate value for the zero order. unit will be, for the zero order we will put the value of n is equals to 0 concentration 1 minus 0 second inverse. So concentration can be written in the form of mole upon liter. So this unit will be mole upon liter second inverse. So further it will be mole liter inverse second inverse. So this is unit for zero order reaction. Similarly, we will calculate for first order first order reaction. So we will put in this formula unit. So concentration will become, so value of n is 1. So we will put the value of n 1 minus 1 upon second multiply by second inverse. So concentration power will 0 upon second inverse. Any power, if any power is 0, it will become 1 and it will become second inverse. So unit for first order reaction is always second inverse, and for zero order reaction is mole liter inverse second inverse. Similarly, we can calculate for second order reaction. If we will put second order n value will be 2. So for second order reaction value of n is 2. We will put value direct here for second order reaction. Second order reaction unit will be concentration 1 minus 2 second inverse. So we will get concentration minus second inverse. So this is second minus, so it will be, concentration can be written as mole upon liter. Since the inverse, so it will be already be inverse, so it will liter mole will be become at inverse and second inverse. So we can write it as unit of second order is mole mole inverse liter power 1 and second inverse. So this is, say, for unit for different we can calculate by using this formula. So that's for today. Hope we will meet in the next video. Thanks for the watching video. Thank you.